For those that don't know me, I'm Javier Velázquez, and well, for this plenary, I will be presenting the new component that recently has been accepted as a module development group in TerraFlow SDN, which is the NSC. And yeah, I will present it for you also for this plenary, as we are parallelly conducting the Hackfest that we started yesterday. So for the agenda, I will show you the architecture of this component, and I will show the current status of it and the roadmap of developments that we have in mind. Okay, so let's go with the architecture. This is more or less what we presented here. The idea of the ITF network slice controller is a controller that was born with the idea of covering a gap that there is in 3GPP regarding network slicing the transport network, because in the 5G network slicing defined by 3GPP, they relied the connectivity of network functions in the network for another external management system. So the idea is that the ITF covers this gap in order to orchestrate this connectivity between RAN and core elements in the 5G network. But well, this is not only restricted to 5G use cases, as these network slices can be implemented in data centers, private networks, and many use cases. So the ITF defines this network slice controller as a controller that orchestrates the request realization and lifecycle control of ITF network slices. And it defines two main interfaces: a northbound interface that consumes network slice requests in IETF service request format, and then it implements them using a specific underlying technology that, in this case, would be a specific call to TerraFlow SDN controller. Okay, so well, this is more or less the idea that I wanted to represent, that the NSC is like this link between these two organizations, no, covering this gap. And looking to that, this component is joining these two domains and is managing this call. So in the architecture defined by the ITF, you see more or less that there is an orchestrator up there that could be a 3GPP orchestrator managing the end-to-end slice that would call this controller by using this network slice service request that is defined in this graph, that soon will be an RFC, where a YANG model is defined. And this request would come to the network slice controller that will translate this request to a specific network configurations to the network controllers in the different area domains. In this case, we would put, I will telepoint it. So this way, the network controller here would be located to TerraFlow, so it will be a request to TerraFlow to configure the different devices at the data plane. Okay. So the ITF divides this network slice controller into two main components: a mapper and a realizer. Basically, this mapper is an important component that gives context to the network slice controller of the whole topology and the whole network. So basically, it receives the request, and probably it would ask some external planner components, such as a PC, a path computation engine, or other external components that have more context of the whole topology, to process this request and prepare the end-to-end request in the transport domain for the realizer. So then the realizer would process this request and it would allocate a concrete technology for realizing the slice. This could be segment routing, VPNs. It is not strictly defined, as the IDF what basically does is defines a theoretical, let's say, implementation, but it not specifies how this is implemented. Okay, so going on with the current status of the component, well, this component has been integrated into the Teraflow SDN ecosystem. The current architecture is something like this. This component is now processing requests from 3GPP or IDF. This 3GPP is expressed in the network resource model defined in the, well, I don't remember the technical specification that was defined. And the IDF requests that are processing are defined in the RFC that defines the whole IDF framework of slices. Then, depending on the request coming here, this translator component would translate the request into the IDF slice intent. In case it comes in IDF, it just bypass this translator. And then the IDF intent processor, currently, it does not perform nothing really specific, but the idea is that this module here would be the one asking for more context of the request, would ask for available resources to know where to deploy the slice. And we put here that well, it is somehow we are working on interfacing it with a PC component to extract and to select the path for traffic of this request. And also we have the idea of working on NRPs, which are defined by IDF, which are basically network resource partitions that basically they divide the underlying network in different pieces. So it's easier like to take some pieces of that to allocate the slice. Then this info would be sent to the realizer, which it has a first module that selects the technology that it is going to be used to realize the slice. So it is not currently decided how this module selects the specific technology. How can he know the technology to use? But in any case, then this would select the specific technology, which at the moment only layer 2 and layer 3 have been developed. So this would call the different these two methods. And basically what it is doing here for Teraflow is building a specific service template for deploying the layer 2 VPN or the layer 3 VPN. Okay. We put here also that it is compatible with this equipment called CN Network Emulator, which basically emulates a channel with some specific characteristics, and we use it in some demos and so for only focus on control plane and not what it is performing data plane. So going on with more status things, as I mentioned, the interfaces of this network slice controller for the northbound, it's working supporting 3GPP requests and ITF network slice requests. And for the southbound, as I mentioned, we are currently supporting the specific Teraflow service templates, but we have the idea to support the ITF layer 2 and layer 3 network models to be more standardized and call the Teraflow MBI to with these models. Then the API that is currently operating has the typical root operations, create, read, update, and delete. But only the one that has been tested and works more is the create. And we are working mainly in the Hackfest. Some of the challenges are therefore working on the mainly on the modification and deletion of slices at TerraFlow level. And well, yeah, the NSC has a slice database that stores the information about the slice, and it can be read via the API by the read methods. And also, well, we have a web UI that we are planning to integrate with TerraFlow SDN web UI, where we could also send the slice request there to deploy the slices. And well, I wanted to show also the roadmap we have in mind. So for this, well, there are a lot of elements, and as I show here, for example, we have from TerraFlow some features. We are working in the Hackfest. The one with more priority is using the TerraFlow MBI to create this layer 2 and layer 3 VPNs. Also working on improving these realizers of layer 2 and layer 3 to use the IPF standard templates. And we also have other realizers in mind related to the optic part and also to before, which we will discuss later, UVT. And well, here there are also more roadmap features, like for example the web UI that's its priority is higher, unitary test, slice, well, the verification, deletion of slices, monitoring of slices, also support for other network controllers. Yeah, I won't go very deeply into that, but yeah, we have many things in the roadmap in mind, ones with more priority and ones with less. And well, in the Hackfest we are working on some of them, most of them related to TerraFlow, in order to get them as soon as possible and to have a good Hackfest for that. So